Hello guys, welcome to my channel. Today we'll be solving a problem from GFG, which is job sequencing problem, and this is a problem with medium difficulty. The problem statement is given a set of n jobs where each job has a deadline and a profit associated with it. Each job takes 1 unit of time to complete and only one job can be scheduled at a time. We earn the profit associated with the job if and only if job is completed by its deadline. Find the number of jobs done and the maximum profit. So, two things to note here in this problem is one, we have to maximize the profit. So, when we have to maximize or minimize something, we think of greedy approach. So, here in this problem, we will try to apply the greedy approach. And since it is clearly mentioned that we have to maximize the profit, we'll try to do something with the profit itself. Okay. And the second thing to note here is the job is completed by its deadline. So deadline is the second important thing which we have to keep in mind. So now let's just look at the example. Here n is equals to 4, jobs is 1, 4, 20. So 1 is the job ID, 4 is our deadline, and 20 is the profit associated with it. Since we have to maximize the profit, so we will greedily think, okay, which job has the maximum profit, we'll pick up that job first and finish it off. So which job has the maximum profit? This job, right? So we will take this profit. Okay, so 40 we will take, and then we look for another job which is having maximum profit. So next job is this one, but can we take this job? No, right? Because this job also has deadline 1 and we have already taken the job which we have to complete by deadline 1. So we can finish only one job from these two because both have the same deadline. So we cannot take this. So next job with the maximum profit is this one. So this job has deadline 40. Can we take it? Yes, we can take it. So we'll add it in the profit 20 and our profit will be total 60. So now let's just look at another example so that I can cover all the corner cases and explain you how we can go about the solution. So here in this case, we have to maximize the profits because the problem statement clearly states that we have to maximize the profit and also we have to take care of the deadline of the job. But our main intention is to maximize the profit. So what will be our thought process behind this is, let's say we can sort the profit array. Also, whenever we are thinking, okay, we have to apply greedy approach, then sorting will be there. Okay, so let's just sort this array. So now I have sorted my array based on the profit. We have to also keep a look on the deadline. In a normal scenario, if I am given a set of tasks and I have to perform the task based on the deadline, my thought process will be job with the maximum deadline, I'll try to perform it in the end, and the jobs with the less deadline, I'll try to perform those jobs earlier. So here, for example, if I have total deadline of 5, I'll take an array of size 5. Actually, I'll take an array with size 6 because of zero base indexing. So this array is basically representing the deadline. This anyways will not be using. I'll put -1 in the array list. So the idea is, if I have deadline of 5 to perform a task, I can perform it on day 1, I can perform it on day 2, 3, 4 or 5, right? Because it has deadline 5. But if I have deadline 1, I only have option to perform that task on day first, else I'll not be able to perform that task. Okay, so just keep this thing in mind. Let's just go through the problem. So here first I am taking this job. The profit is 120 and deadline is 2. What I'll do is, I'll take profit and count and initialize both to 0. Okay, so this job has deadline 2 and on day 2 I'm not doing anything, so I have the bandwidth to take this task. I will take this task 4 here. I'll increase my profit to 120 and I'll increase my count to 1. So now again I will see the next job. It has profit 110 but deadline is 2. On day 2 I am busy. I cannot take this. But can I perform it on day 1? Yes, I can take it on day 1. So I'll take this job ID 7 here. I'll increase the count to 2 and I will increase my profit to 110. Then I will again come and look at this job. This job has deadline 3. On day 3, am I doing anything? No. So can I take this? Yes. So I'll take the job ID 2. I will add 100 here to my profit and I'll increase my count to 3. Now looking at this job has deadline 1. But am I free on day 1? No, right? I have already doing job 7 here. So I cannot take this. Can I do it on day 0? Day 0 is not available with us because the deadline is starting from day 1 here. So I cannot take this task. So this we cannot do. So next job is, it has deadline 5. I am free on 5th day, so I'll take up this job and I'll increase my profit with 60 and increase my count to 4. Again on day 5 there is another job with profit 30. Can I perform it on day 5? No, because on day 5 I am already doing one job, but I can perform it on days 1, 2, 3, 4. So I'll go from 5 to 4 and check, can I perform it on 4? Yes, I can perform it on 4. So here I will take job ID 1 and I'll increase my count to 5 and profit with 30. Let's say 4 would have not been available here. I would have gone to 3 and check if 3 is available or not. So like that, we will traverse backward in the array and check from the day of the deadline to the initial day. If any of the day is available, we will try to perform that task on that day. So here the deadline is 4. Can I perform it on deadline on day 4? No. Can I perform it on day 3? No, it has already some task. On day 2? No, it already has some task. On day 1? No. So we cannot perform this task. We'll cancel it out and this has to be our final answer. We can perform total 5 jobs and profit will be 120 plus 110 will be 420 here. I hope the problem is clear. Now let's just look at the Java and the Python solution. So here what I have done is I have taken an answer array because we have to return two things, count and profit. Now I have sorted the array based on the profit. So here I have to see which is the maximum deadline. So I have initialized a variable maximum, which I have initialized with deadline, first deadline, which is 4. And I have initialized count to 0, profit to 0. And here I am trying to find which is the maximum deadline out of all the jobs which are given. So here in this scenario, the outcome will be 4. Okay. So here I have taken a result array. So as I have shown here, I have taken an array with max plus 1. So maximum deadline was 5. So I have taken an array of length 6 here, and because of 0 based indexing, but deadline here is starting from 1, that's why it is max plus 1. Then I have filled the array with minus 1. Then what I am doing is looping through each job, and for each job from day of the deadline till the starting day, day 1, I am traversing back. If the result is minus 1, so what I am doing here is from the day of the deadline, if that day is available, then fine. Else, go back and see if this day is available. Otherwise, go back and see if this day is available. So that's how I am traversing back. So that's what I am doing here. I'm looping through each job, and for each job's deadline, from the day of the deadline till the starting day, I am looping back. If the result is -1, result as in if that day is available, if I am not doing anything on that day, I will add my array, my job ID there, and then I will increment the profit, I will increment the count, and then as soon as I find one day at which I can perform the job, I'll break out through this loop and I will go and check for the another job. And in the end, I have pushed the count and profit to my answer array and return the answer. So let's just compile and run. So it is working. Let's just submit it. So it is working. Let's look at the Python solution. In the Python solution, I have done the same thing. I have sorted the array based on the profit. I have done reverse equals to true because we have to sort the profit based on descending order. Here, I have again taken the maximum of the deadline. Then I have taken profit and count variables. And then I have initialized a result array with maximum deadline. And same thing I am doing for each job and for each job's deadline till the first day. So this is a reverse loop. If the day is available, then I am incrementing my count, then I am incrementing my profit, and then this particular day I will assign that job to it and I will break after that and I'll return the count and profit. Let's just submit this as well. So it is working. Okay. The time complexity for this problem is order of nlogn for sorting and order of n cross m. Why n cross m? So we are using two loops here. One loop is for n jobs and other loop is for deadline. So let's say m is the maximum deadline I have. So here in this case 5 is the maximum deadline. So m is the maximum deadline that I have been given. So order of n cross m, and space complexity is order of m here because I am taking a array with maximum deadline. So space complexity is order of m and time complexity is order of n log n plus order of n cross m. I hope the problem is clear to you. In case you have any doubts, please add it in the comment section below. I'll try to answer. If I helped you in understanding the problem better, please give this video a thumbs up and also please subscribe to my channel. It will encourage me to create more content like this. Thank you.